I just want to draw. It's not that big. Maybe I use Notepad. Or paint, I guess. Just imagine this is my whiteboard. Okay, so say you want to add two numbers together. And usually what you do in the order is you would say, you know, 3 plus 5, and then you hit the equal sign and it would tell you what the answer is, right? But then we have more complications. Sometimes we get confused about what gets done first, this order of operations problem we've had. Okay. The question is, now let me try it this way. So which one comes first? So you look at that and you go, well, if I'm going from left to right, I do the 3 plus 5 first, and then I multiply times 4. But again, in math class, they say the order of operations, the multiplication has to happen before the addition and subtraction, right? And so to be clear then, you have to put in parentheses to do that. Which requires your calculator to have a few things on it. First, it has to have parentheses on it. And then next, it has to remember what the first operand is, because you can't see it once you type in the second one. So you would type in the 3, and then you would hit plus, and then you type in the 5, and the 3 would disappear, and now you can't see the 3. And now you say equals, or I guess you do the times 4. Now you've lost the first thing, and you don't get any intermediate values either. So a lot of engineers and architects like to do their math a different way. And they like to do it using reverse Polish notation. What would this look like in reverse Polish? Let's say you would say this. You'd say 3, 5 plus 4 times. Looks very strange. And so what you do in reverse Polish notation is you put your operands first. So I put in the 3, I put in the 5, and now I say plus. And what will happen is it will add those together, and you'll see that value on your screen. And then you put in the 4, and then you hit times, and then it'll give you the answer to the equation. Do you have to put parentheses in? No, you don't really need to, because you're being very explicit on the order you want these to go. Now, if you have more complicated ones, like say our original equation was, it's a lovely sound. What's going on here? Oh. So let me put in another equation then. Maybe that same equation. So this is the equation we want to do. Just add one more thing. So that would be standard notation. And what would this look like in reverse Polish notation? Would be 3, 5 plus 4, 6 plus times 3 divided by. Okay, see that? Kind of weird looking, right? But it's really easy to do evaluation of the expression if we use something called a stack. So we're going to talk about a stack today. All right, so a stack. If you're doing reverse Polish notation, it's a good way. It's a good data structure to use when you're doing expression evaluation. We look at. I imagine you ever go to what do they call that place? Where's that pizza? Izzy's, right? Izzy's Pizza. Is that still open over by Washington or over by the Fred Meyer store? I don't think so. I think it's changed hands. Maybe it's still there. Well, if you ever go to Izzy's, they have a big salad bar, right? And they have all these refrigerated plates in the salad bar, right? You grab a plate for your salad and you go get some salad. And it's a stack of plates, and it's got this spring-loaded thing, so as they load it with plates. Now there's a big problem with that because they want the plates to be cold, but to load the plates, they take the plates that came from the dishwasher that are really hot and they put them on the stack, right? But that's not great because then you go and you grab the plate and it's still really warm from the dishwasher. It would be better if we took the plate off the bottom because those plates have been there all day. So for Izzy's Pizza Parlor, a stack would be a really bad choice, but that's the way they do it. You know, it'd be nice if you could just take the plate off the bottom, the one that's really cold, and get some salad. Well, we have the same problem here. Well, yeah, so let's talk about the order then things go on. One's called FIFO. FIFO. And the other one's called LIFO. Funny names. So FIFO stands for first in, first out. LIFO is last in, first out. So which one do you think a stack is? Is a stack FIFO or LIFO? Anybody? Think of those plates at Izzy's. So you're the dishwasher, you load a plate onto the stack. Now here comes the customer. Which plate are they going to grab? The one the dishwasher just put on the stack or the one on the bottom? That's the top one. So it would be this one, last in, first out. Because, you know, you have your stack of plates. Here's our stack of plates. And then you add one more plate to the top. Now here comes your customer, and they're going to pick up that last plate that was just added to the stack, which is, again, nice and warm from the dishwasher. Okay? But when you're doing reverse Polish notation, a stack is a really cool way of doing mathematics. So we're going to create a little mini stack for ourselves, which is kind of weird. All right, so here's our stack then. Here's the bottom of the stack. And stacks grow from the bottom to the top. And we're going to do this equation. First thing we put on the stack is the 3. Now, how is your calculator going to tell the computer that you're done with typing in numbers for the first operand? What the user will enter, and this will be the list. Like if you're trying to imagine the key presses on our calculator, you would type in a 3, and then you would actually, we'd add an enter key to our calculator. So you're just entering that value. Say you had 34, you'd just put 34 enter. Okay? So you need a way of showing that that's the end of the first operand. So we put the 3 on the stack. Let me see if I can get a better pen. Like 12 million pens, and they all disappear. So frustrating. So we put the 3 on the stack. They hit enter. Now we put the 5 on the stack. Right? You include that, and then it says do the first operation, which is our plus operation. So you pop these 2 values off the stack, 5 and 3, and you add them together. Once you've added them together, you clear that off the stack and put the result now at the bottom of the stack. So you when you say you pop a value off the stack, that's the terms they use actually. Pop and place, I think. So you pop the 2 values off the stack, you do the operation, and return the result back to the stack. Now we have an 8 there. What made it do the part there? Basically, the inclusion of the plus sign. Plus sign requires 2 operators. It's a binary operator. It needs to add 2 things together. So it just grabs the top 2 things on the stack, adds them together, and puts it back on the stack. Next, we do 4, 6. So we put a 4 on the stack and a 6 on the stack. Notice our stack is growing. 4, enter, 6, enter. And then our operand is, our operator is the plus again. So we pop the top 2 values off the stack, 6, 4, and then we apply the operation. And that gives us 10. So these got popped off. So we push on a 10 onto our stack. So now we have a 10 and an 8 on our stack. And then what we have is a multiplication after the plus sign. Well, that's also a binary operator. So we pop the 2 values off the stack. We have 8, but this time we're multiplying them together, right? We get 80. And we take our value and put it back on the stack. Okay? So our stack is where we're going to be storing the result of all our little equations. Next we have a 3. We put the 3 on the stack. And then we have the division, which is a binary operator, so we pop the 2 values off the stack. And 30 divided by 80, or 3 divided by 80, and that's the number that gets stored here. Anybody know what that is? I'll just make up a number. 0.67 or something, okay? But when you're done with the equation, notice that you know you're done because there's only one thing left on the stack, and that's the answer to the whole equation. Pretty neat. Okay? So what I'd like to do with our calculator, we haven't done the plus, minus, division, times, equal button. We haven't done any of those really yet. All we have is we put in a number, we hit a function. But I'd like to make it so that we could evaluate or be able to calculate expressions written in reverse Polish notation and come up with the value for our equation. Okay? Then it forces you to rethink how you do math. But again, when I had a calculator in college, this is the kind of calculator I had. Because it's really clear the order you do stuff. There's no parentheses, you just do them in that order. But it takes some time to get used to the notation. So that's our new assignment on the calculator. But we have lots of things to talk about. First, we have to simulate a stack. Luckily, Java has a stack data structure I'm almost sure of, so we're going to go find that, and we'll use that for our calculator. So I'm going to do the first one, which is maybe the addition operator. And you might follow along there while I'm doing it. Okay, so where I left it was you could do things like this. Seems to be working. So we're going to try to activate these over here. First thing we might want to change if we're turning this in reverse Polish notation is we no longer need an equal sign. Because anytime you hit an operator, it's going to calculate something and put that on the screen. So instead of an equals button, we're going to reuse that button to be the enter button. Okay, so I'm going to change the text on the button to enter. So let's go to the calculator then. Doesn't do anything. So I go out here and we're going to change the text on that to just say the word enter. Too big. So on the font, I'm going to make it a little smaller. That didn't seem to help. Yeah, it's pretty tiny, but gets the point across. All right, so let's go out and take a look around in the Java library to see if we can find a stack data structure. Here's the push down stack. You push values onto it and pop values off. Oh, what a mess. My hope is it just has a stack of probably more than I wanted to know. See, what I'm looking for is a predefined stack structure. Doesn't look like there's a data structure that allows us to do that. You guys see how they're using an expression evaluation? See right here? Here's the reverse Polish version of that. What I'm looking for is some generic coding. So like here, see where it says stack? That's what I'm looking for right there. It's a generic stack class. So let's add that to our code. Question is where to put it. We're going to put it at the bottom with the private instance variables. Maybe here. So we say stack. Something like that. Let's see. Add import for Java util.stack. We'll do that. And here we're going to have a stack of strings. See what it doesn't like about that. That's what I'm doing. Okay, let's go check to see. Oh, I see. Strange. So the syntax is kind of strange. There's a new feature added to Java just recently called generics, and one of the generics that they added was this stack idea. When you're creating a stack of stuff, you really don't care about the plate so much as just the process of stacking the data up. So instead of having to write a stack class for the string class and for the int primitives, they'd have to write a stack class for each one. When the stack code would not change at all. You're still stacking things up and taking things off the stack. So what they've done is they made that generic. And so the syntax for generics is you use an angle bracket. Notice I didn't say less than. That's an angle bracket. And you wrap it around the things you're going to put in the stack. Now remember, our numbers are just strings, and we convert them to numbers later. So we're going to create this new stack of strings, and it'll be ready to go. Okay. So we have our stack of strings. There's nothing really on it yet. And if we look at the start of our equation here, 3 plus 5, let's just do 3 plus 5 and see if we can get that to work. Maybe that's my goal today. Now remember, our equals button has changed meaning, so we probably need to rename it. Let me go to properties. We'll check the name. We're going to call this button enter instead. And then I'm going to double click on it. I guess I didn't have it yet. So this is where we're going to put our code. I think what would be the best way to do this. Okay, so we say my stack dot push, and we're pushing on what's currently in on our screen. So that'd be text I think we had called it these are all buttons. What's our top text box called? It's been a while since I looked at this. I don't see. Oh, there it is. Text input. Notice how I use this keyword to help me get a list of things I could do, and then I just get rid of it because it's not necessary. But it helps me find what I need. That's it. So you take whatever text they have up in the top, and you push that onto the stack. Boy, that was hard. Everybody get that? Got our enter button, and we use our stack to push on that value. So we put in a 3, we press enter, we put in a 5, we press enter. We have 2 things on our stack, and now we hit the plus sign. So what should happen? So I'm going to the plus sign here, generating an event, and here's the spot where we pop things off the stack. So you would say so the first operand, I guess. There's the second operand. And we're going to get those 2 values off the stack. Now remember, the things on our stack are strings, and so we have to convert it to a number. There's pop. Didn't like that. Hang on. First double, my stack got pop. It's not liking it. Object can't be converted to a string. Okay, so we're going to have to do it this way. That's really clunky. Sorry, it's just things about Java I just don't like. This is one of those times. Okay, so you go to your stack, you pop off that value, and you cast it into being a string. And you take that string, send it into parse double, and that will change it from the symbols, 3 or 5, into the actual double, and we actually get the value we need. Do the same thing with operand 2. Same code. You pop the next value off. And then you want to show it in your text box. So then you would say text input dot set text. And then we would say plus, we haven't done the operation yet. Yeah, I think that would be it. So we add operand 1 and 2 together. Those are both doubles. We get some number. We paste that onto the end of the empty string. That converts it into a string, and now we can show it in our text box. So just to walk through it one more time, we have 2 operands. First operand, we go and pop the stack because it's already there, let's say. Grab it off the stack, convert it into a double, and store it in operand 1. Get the next thing on the stack, convert it to a double, and store it in operand 2. Add those two together because we're in the add button, right? And then we put it back out on our text. So let's see if that actually works. I don't see our frame. Oh, there it is. Okay, so I say 3, enter, 5, enter, plus, and I crash. Why would that be? So when your program crashes, you get a runtime crash. It tells us where the problem happened. For me, it happened right here. Looks like my stack was empty. Another problem we have is when we hit enter, we need to clear the text box because we don't want to keep adding to it. We want to get it ready for the next number. So let's look at the enter button. So here we'll say text input dot text. So we forgot to get the text first of all. That's probably why it crashed. Okay, so we get the text out of the text box. So make sure to add that. But then after you get it, you want to set it back to 0 or you want to clear it. So you say text input dot set text. In this case, we just want to clear it. and that will blank it out. Or actually, we want to put a 0 there. Okay? There's our 0. Let's see if that fixed our problems. So 3 plus, and I crash. Oh, that's right, I'm not doing the right order. Okay. Let's restart it then. Yeah, I say 3, enter, 5, enter, plus. Wow, it worked. Okay, so that's the basic structure for doing one of the multiplication, division, addition, all of those. Not a lot needed to be added. What we did was we added a stack to our private instance variable. We probably should say private here. Okay. I think it's private by default, but it's good to state it explicitly. Syntax here is kind of gnarly. We'll get to this eventually, but just think of a stack of plates. That's the way I think of it. When you grab a plate, that's called a pop. When you push the plates down, put one on top, that's called a push. Push and pop. And this is really our first data structure we're using here, so that's kind of neat. Change your equals into an enter button. Replace it with this code. And then when you actually have the addition button, let's see if I can find it. Yeah, here's addition. So you'd make this like the others, but the only thing different there would be where you have the plus sign between the two operands, you changed it to whatever operation you're supposed to be doing. Like if you're on the subtraction button, you put a minus there. On the division button, you put a divide. Okay? That code is going to be the exact same except for that plus sign. That's where you do the operation that you're trying to do. Remember when you're testing it, the order you put stuff in is you put in the operands first, and then you hit the operator, and it should show you the result of that. There's a couple other things I need to fix. I'm going to work on that offline, but that's the general idea. Yeah. Yeah. Any other questions here? Okay. Yes, I'll be around to help as well. But there's still one more issue we need to solve. I'll get to that in a second. Let me stop the recording though.